Clinton Carter, thank you so much for joining me here today at the Titans of Nuclear headquarters.
Well, thanks for inviting me, Bret.
Yeah,
it's great to be here.
I'm excited to learn about your role at the Utility Service Alliance. Is that how I say it?
That's correct.
But before we get there, we always like to hear someone's story. How did you get into the energy and nuclear sector to begin with?
Well, I grew up in Kansas and had worked for an engineering firm as I got into college and became interested in engineering. And so ultimately, I looked to nuclear engineering. I was fascinated by the technology and basically the nuclear magic that happens to generate power.
So your undergrad degree was in nuclear engineering?
Yes, undergrad from Kansas State.
Cool. And does Kansas have any nuclear power reactors right now?
They have one station, Wolf Creek Nuclear Operating.
That's Wolf Creek. And when you grew up, did you remember, was there talk of the nuclear reactor? Do you remember what it was like?
Well, the reactor was under construction at the time, and so we were all aware of it, and I thought it was interesting technology, and just looked like something I'd like to explore and be a part of.
Cool. So what was your first job out of school?
Straight out of school, I went to work for a nuclear power plant that was under construction in Texas, the Comanche Peak Steam Electric Station at the time.
What kind of plant was that?
It's a 2-unit, 4-loop pressurized water reactor, Westinghouse design.
Cool.
Yeah.
And what did you do there?
Well, I had a number of various assignments. I started out in an emergency planning role, ultimately migrated into operations, licensed as a senior reactor operator, went on shift for a number of years. So I had assignments in engineering, nuclear administration, reliability programs, and that sort of thing.
Wow, full smorgasbord.
Exactly.
How many years was that for?
I was at Comanche Peak for 20 years. Yeah.
Wow.
So,
what the role that you started in? You said that was emergency planning.
Right.
What is emergency planning?
Well, the idea there is every nuclear power plant, as a part of their license basis, they have to be prepared for any potential event at the plant to protect the health and safety of the public.
Mm-hmm.
And so it's required by federal law that we have plans for evacuating personnel and responding to any design basis accident that might happen at the plant. And so I was involved in writing emergency plan scenarios, basically drill scenarios, so that we could demonstrate our readiness to the Nuclear Regulatory Commission to receive our operating license for the plant and be able to safely and reliably operate the station.
And what are these scenarios, these design basis scenarios?
There are numerous design basis scenarios. There's scenarios where you have a leak from the reactor coolant system that you have to respond to and protect the core. There's other accidents or design basis accidents where you may lose power from off-site and you have to have systems on site to maintain the safety of the reactor and power all the safety-related systems. There's many of those that you have to be able to demonstrate your capabilities to respond to, and every plant does that.
And you mentioned one of them was like evacuation procedures.
That's right.
Is that for the plant personnel, or is that for the general public, or what does that look like?
All right. It's actually both. So you have it depends on the severity of the accident and whether fission boundaries are being compromised between the reactor core and the environment. So there's procedures to evacuate non-essential personnel at the early stages of an event that may just be limited potentially to the site itself. There's other procedures that where you coordinate with local law enforcement to evacuate up to a 10-mile radius around the power plant during more severe events.
Interesting. And that one where it's up to 10 miles around the power plant, has that been rethought at all since Fukushima, where they did the evacuation and then after they looked back, they realized, oh my God, the evacuation actually hurt more people than the radionuclide contamination would have? Have we redrawn up our emergency plans to think of evacuation in a different light now?
Not to my knowledge. The way that we came up with the 10-mile emergency planning zone, EPZ, is a function of the reactor core and the potential consequences of of that radioactive material getting into the environment and then dissipating as it moves downwind. And so the analyses for the type of plants we operate in the United States, within a 10-mile radius, if you can efficiently evacuate that demonstrates that you can protect the public that would be most directly impacted for the event. Longer term, post immediate actions, if there was a longer term type event like a Fukushima or something that was quite devastating, there's a longer piece of this where you bring in State Bureau of Radiation Control and other entities and go all the way out and to track the impact out to 50 miles. And so that was the original design basis of my particular plant.
Where did you end up after Comanche Peak?
Well, after 20 years at Comanche Peak, and I had an interesting experience while I was at the plant. When I was in operations, I got involved in a new initiative that was technology-based.
Cool.
And it was to look at how we could modernize our internal plant processes to improve efficiencies through the applications of wireless advanced technologies. And so that led to us ultimately building at Comanche Peak the world's largest industrial wireless network in one of the most complex environments in the world, a nuclear power plant. And so we had near 100% coverage, and it was basically today a very commonplace 802.11 Wi-Fi technologies. Putting that into a complex environment in accordance with regulations at a nuclear plant was quite an event. And we used that infrastructure, over 400 access points throughout the facility. We used that infrastructure to enable more point-to-point voice communications between the workforce, improve workforce efficiencies, mobile computing, and equipment condition monitoring through wireless sensing technologies. And so as that project wrapped up, we had a sort of a visionary CEO at the corporate level at that time at my company. And he was interested with this new and emerging internet. Could we do something from a central facility to help improve performance and reliability of our larger generating fleet? And so I got involved in putting together a business case, and ultimately building a corporate advanced monitoring and diagnostics center for our generating fleet in Texas, which we call the Power Optimization Center. And that was a direct outcome of the wireless work that we started at Comanche Peak. And so for the past 15 years, I've been a part of the organization in our corporate offices where we've taken that small monitoring center and scaled it up to a robust 24/7 remote monitoring facility. And we're currently monitoring power plants coast to coast. We have over 50 stations, over 100 operating units that we're monitoring 24/7 to optimize their safety, reliability, and performance.
Amazing. Tell me, you mentioned before, due to the complex nature of a nuclear power plant,
Correct.
What characteristics of a nuclear power plant make it particularly complex to install Wi-Fi access points?
Well, we talked earlier about design basis accidents, and so many of our regulations are designed to preserve that power plant's capabilities, the power plant environment, to ensure that if there were some sort of upset in the plant, everything's in the state that it needs to be to effectively respond. So think about this: you put a wireless transmitter in an environment where there's sensitive equipment that is needed to respond to a problem with the reactor. The radio frequency emissions could interfere with that sensitive piece of equipment or that sensitive instrument. And so we have to go through all this engineering analyses to prove that, well, no, the radio frequency is being broadcast at the power level. It will not impact that particular component. And you have to do that for the entire station.
Wow.
And things like, okay, if you're going to put some equipment in a plant that generates heat, then you have to go in and do an analysis of the heating and ventilation system to see if during an accident the HVAC system can effectively remove the necessary heat because you're adding another source of heat to the plant. So it is a very complex environment.
What's the extra source of heat? Literally just the circuitry on the Wi-Fi access point?
That's right.
And that would be enough heat to warrant a redesign or at least inspection of the HVAC system?
We would have to demonstrate that it's not an impact.
Right.
That's this conservative.
I see. So the regulations made you, but when you probably ran the numbers, it was like, this is 1/1,000,000th the amount of heat that would disrupt our AC systems.
Exactly. But you have to address every one of those
Wow.
points.
At some point, are we too ridiculous with our requirements?
I think that's part of the challenge that the legacy nuclear industry is facing today.
Yeah.
You rewind a few decades and you think about the beginnings of the industry and the message was, nuclear power, when it's created, it's going to be too cheap to meter. And we weren't too far off from that for many, many years. We were the cheapest source of generation until disruptive technologies kind of turned the tables and resulted in a collapse in market prices and efficiency improvements on the demand side of things, which really has now, while nuclear has it still is by former standards relatively inexpensive, it isn't no longer economic. We can't sustain economic competitiveness with cheaper natural gas right now. And over time, as events have happened, we've learned lessons and things, we've added more and more regulations.
Yeah.
And now, and I've talked about the complexity of making changes in a nuclear plant. So we have, let's say, 30 years of burden that this industry has assumed, and now, from a commercial perspective, the tables have turned, and we find ourselves stuck. It's difficult to change.
So what do we do about it?
So we look for innovative new approaches for complying with regulations.
Yeah.
We engage our regulators. Many of the things that we perhaps, I'll just offer this up as food for thought. Some of the regulatory overhead that we comply with today, maybe it's no longer necessary. Yeah. For example, after 9/11, we made a tremendous investment in security of nuclear power plants.
Yeah.
And the Nuclear Security Department at every one of the stations in our country is the single largest department now. So, but the threat, as we all know, hasn't materialized, but by and large, most of those regulations are still there. And so there are initiatives now, and our industry is working with the Nuclear Regulatory Commission to unbundle some of those regulations.
Okay, so that's a really good point. I'm glad you brought that one up. So what is the holdup? Why aren't the utility lawyers literally camped out in the NRC's headquarters and saying, this requirement is ridiculous. I think we can all agree it's ridiculous. Let's get rid of it. Why didn't given how expensive the department is, isn't it worth whatever amount of legal fees it costs for the utility to just get that requirement out of there ASAP?
We're working on that. Again, it's complex.
Sorry, am I too frustrated here?
No, you're right on target. Again, it's a very complex process, and we are working together as an industry through. We have industry representation here in Washington and through the Nuclear Energy Institute as one example, and they do work with the Nuclear Regulatory Commission on our behalf, and we are moving in that direction. The reality of things, it takes time. And in the interim, part of what we're doing under our DOE Advanced Remote Monitoring Project is we're looking at new and innovative ways to satisfy regulations. As an example, in my power plant, we have operators twice a day go around and take local temperature readings from temperature gauges, local temperature gauges, in over 100 rooms in the power plant, twice a day, to verify that the temperature is within the range it needs to be for those design basis accidents.
Human beings are literally going around measuring temperature.
That's right.
With thermometers.
Well, that's right.
That's crazy.
So the idea is, that's required by regulation. But what if we put we have a wireless infrastructure in the plant now, let's put wireless temperature sensors in those same facilities, and an operator can push a button in the control room and generate that surveillance report.
Right.
And that right there saves just elimination of that one surveillance.
Yeah.
Would that's equivalent to one full-time operator.
Wow. And I bet you got a list of 1,000 things just like this.
We have many things where we do things, examples where we do things in a very manual fashion, the way we always have.
Mm-hmm.
And we've built very formal procedures and processes to sustain what works. But now, the opportunity is to take all of that manual stuff that we do to maintain power plants, optimize those processes, and then apply modern technologies to help us improve our efficiency so we can drive cost.
Modern technologies. Why wasn't this done in the 1980s? I think Honeywell had a wireless temperature monitoring system for houses back then.
Exactly, and they have, and we have many examples where other industries have moved forward with technology, but they didn't have the regulatory overhead that our nuclear power industry has to manage, and so it moves much more slowly. And one thing that we are dedicated as an industry to doing is preserving nuclear safety. And if it takes time, it takes time. But we will not compromise reactor safety, for economic benefit ever.
So what happened next in your career? When did you move on to Luminant?
Well, so 35 years at Luminant, and we talked about the wireless technology project at the plant and how that evolved into our Advanced Monitoring Center at our corporate headquarters. And so 3 or 4 years ago, the Utility Service Alliance, I was contacted by the president of the USA Alliance as the industry started looking at how can we respond to this economic crisis that is emerging. And as an industry, through the Nuclear Energy Institute, we initiated what is called the Delivering the Nuclear Promise Initiative. And as a part of the DNP initiative, what USA was interested in is we see an opportunity. Could we build something like that platform that Luminant uses for monitoring their power plants? Could we do something like that for the USA nuclear plants, modernize, centralize some services for them, and automate some of the things to help drive cost out of the business? So that all started. And so that ultimately evolved to a point where we were meeting with the Department of Energy and trying to seek some funding to help us move in that direction as a part of an industry demonstration. And then once again, through the Nuclear Energy Institute and the Delivering the Nuclear Promise Initiative, we initiated a team activity that was staffed by probably 8 or 9 of the nuclear utilities in our nation to build a framework and a strategy for how we can modernize our fleet using advanced technologies. And so, coming from the work that we did as a part of this NEI initiative, we recognized some low-hanging fruit. And then we went to the Department of Energy, shared the opportunity, and proposed doing an industry demonstration at USA with some of their plants. The results of which, coming out of that study, we would make available to the larger nuclear industry so they could follow in our footsteps, along with a supporting business case strategy that could deliver some confidence on a return on investment if we could work together and go down this path.
Okay, so what's been the result of that so far?
Well, we're just getting started. We were awarded, USA was awarded in the May timeframe this year, a grant from the Department of Energy. All in, but it's a cost share initiative, all in it's a $14 million project to provide this industry demonstration. And so we're finalizing contract negotiations now with DOE. We expect that to be wrapped up here in a handful of weeks, and right after the holidays, we'll be getting into project implementation. And so this project, this Advanced Remote Monitoring Initiative, our objectives are to demonstrate how we can apply advanced technologies to nuclear business processes, nuclear programs in our power plants. And so the idea of putting advanced field sensing technologies throughout the plants to automate data collection and analytics. And so we're looking to emulate human senses throughout the power plant so that we can minimize the number of walk-around inspections that our plant personnel must do just to verify everything's the way it's supposed to be. So cameras, video cameras, infrared sensors, acoustics, those are the type of vibration monitoring technologies. So we'll be emulating the human senses. Well, let's say 4 of the 5. I really don't want to go around and taste the power plant, right? So we'll be emulating that. And also today, modern sensing technologies exceed the capabilities of human senses.
Of course.
And the sensors are cheap.
Yeah.
So general deployment of that kind of technology throughout the facility. And then working with one of the partners in this initiative, we're working with the Idaho National Labs. They have the National Lab System has many very impressive technologies that are ready for demonstration in a production environment. And so we're looking to work with INL to develop machine learning algorithms that can take the streaming data from those field sensors and help us identify by exception when something in the power plant environment is changing that warrants human attention.
Why does that require machine learning algorithms and just not normal software?
Well, you could do it with normal software, but ultimately you'd be limited. That's exactly where we want to start. And our project is really a 3-tiered, 3-phased initiative. First, just as you asked the question, basic monitoring and alarm technology. That's a tier 1 initiative. And so we've been doing that kind of thing through Luminant's Power Optimization Center for 15 years now.
Yeah.
So that's and we're sort of at that point where we need to take that next step to derive further value that we see. And so the next step is the establishment, and we'll begin constructing this, a shared services technology platform for the USA members. And on this platform, as we develop modules for online modules that will pull in the data from the plant and do the analytics on it and give us the results, where machine learning algorithms come in is as things happen in the plant, we experience things, we'll learn things. And so we will capture those fault signatures and those failure signatures from all the participating plants as they emerge, capture that fault signature, humans will put that back into the platform, and then in the future, when similar symptoms start emerging somewhere in some plant on some component or system that's being monitored, the system will say, hey, we think it's this has a 78% correlation with a previous failure mode we saw on a pump like that at another plant 2 years ago.
So I guess I'm still confused though why it has to be machine learning, because what I'm hearing so far is you just want predictive capability out of your software, but that doesn't require machine learning. That's still software, that's still just general software that allows predictive maintenance. The one thing that I'm very hesitant about in encouraging the use of AI or machine learning in the nuclear space is that the regulator, and probably rightfully so, requires that they understand the technology that goes into a nuclear power plant. And the whole thing behind AI and machine learning as it is constructed today is that we don't understand it. We specifically write code and algorithms that if you pump enough data in, they'll pop out a result that correlates to what you want, but we do not know what's happening in that black box of computer code. And so what my fear is that if we rush to try to bring this technology to fruition, all we're doing is welcoming a $500 million review from the NRC that goes absolutely nowhere, whereas we could have just used non-buzzwordy normal software technology, such as just normal predictive software and not machine learning, to accomplish our goals.
Right. So that's a great question, Bret. And I'll actually be at NRC tomorrow, probably having a very similar conversation with their research and development team.
Yeah.
So the idea here is view this as supplemental monitoring. And so when we get to the machine learning and the AI components, so we are still complying fully with all regulatory requirements and delivering all of the surveillances, everything that's required, quite capably and competently. And we will go through formal processes for anything we apply to satisfy regulations. This is above and beyond that. This is saying, hey, we can learn something about this environment. There's something abnormal going on in this part of the plant. It's not required by tech specs or regulations that we identify that immediately. This is giving us advanced indication of something at a very small level that we can learn from. and avoid. So when these regulations and these plants were licensed, this kind of technology didn't even exist. It wasn't considered. Now, it's reasonable to expect that as we gain experience and confidence, that some of this could be used. I think predictive technologies, basic alarming based on that, that's where we find ourselves. Yes, that's ripe for satisfying PM requirements, maybe doing taking credit for monitoring of the plant to satisfy other tech spec requirements. So we can do that now, but where we get into the area where it's a little bit abstract and uncertain exactly what this is going to tell you, because you don't know what you're going to see. I think a good example might be, say we're monitoring a power plant environment in the area of the turbine, big turbine building, lots of pipes and steam and lots of energy in this environment. And this plant, let's say the plant trips from 100% power, and it automatically and safely shuts down. And now let's come back and say that we return the plant, figure out what the problem was, solve the problem, bring the plant back up in power full load. Now we're back at full load, and one of our acoustic sensors generates an alarm. And it says, hey, there's some sort of low frequency harmonic over in this area of the turbine building. It wasn't there before the power plant went offline. And so maybe we ought to go look at that. And that would even be beyond human sensory perception if they were in the area, but technology says there's something going on there. So we go and we find a broken pipe support, and we repair it, and we avoid a forced outage somewhere down the road.
Listen, I couldn't agree more that software is an amazing thing to run power plants with. Could not agree more. I guess where I just express hesitance is when we kind of rush to deploy extra technology like AI, machine learning, just because it's something everyone can agree on, because it's become a buzzword in common nomenclature, without actually taking a step back and saying, listen, the industry has economic problems. What are our problems to solve? Let's go after the cost drivers. Let's forget about the buzzwords, and let's just focus on applying whatever technology is best to solve the problem.
Well, I think that really is the underlying objective of what we're doing. This is an industry demonstration. We aren't going to be changing any of our compliance standards as part of this. We are going to deploy some technologies, apply it in new and innovative ways that has never been done before in our power plant environment. And at the conclusion of this 3-year initiative, we'll capture the lessons learned, we'll capture the value that we've seen, we'll take a look at what gaps exist and what might be possible if we took this technology at a demonstration level and scaled it to full production. And if we have confidence that we can satisfy regulatory requirements with this, then we will go through the formal license change processes with our regulator to make that happen.
Clem, what are some other problems that you've kind of seen in the industry throughout your career that you think, beyond your position right now, but that you think somebody should be working on?
I think we need to take a look at the larger nuclear industry. We've got multiple stakeholders, and everybody is focused on doing their best to support the industry. I look at Congress, for example, passing quite a bit of legislation promoting and supporting research and development and enhancement of regulatory processes to support next generation reactor technologies, small modular reactor technology, and that's all fantastic. What I don't see coming from Congress is any legislation whatsoever that is focused on the legacy, our existing nuclear generating fleet. I'm concerned about that because maybe we're kind of giving the legacy industry a bit of a bum rap. We talk about old nuclear technology and we need to move on to safer and more intrinsically safe and small, and that's all terrific. I think about the existing fleet of nuclear power plants in this nation. They have achieved a level of a safety record that is unparalleled and has never been matched by any other industry in the world. They've done that. There's nothing outdated or old about nuclear fission. That is a very, very robust and sophisticated technology, very mature, that we understand. And so those generators, right now we risk, simply because of economics, a fourth of our generating fleet is most likely going to shut down if nothing changes in the very near future. And it may be sexy, to invest in next generation technologies, but here you've got a fleet of generators that is the envy of every other industry and every other nuclear operation around the globe. It makes perfect sense that we preserve our current investment and that we sustain, by sustaining economic competitiveness, enabling us to preserve that footprint and establish a bridge to future generation nuclear technologies and give them time to go through their testing processes and their licensing processes, pilot plants, and ultimately being able to scale up next generation. That's going to take a few years, if not a few decades. And then I think about, okay, we're talking about electrification of transportation. Fabulous idea. Well, this country simply does not have the generation capacity, the infrastructure right now to electrify the transportation industry. And so preserving nuclear for the benefits of our nation while we continue to develop new nuclear technologies and allow it time to scale, it makes sense.
Clayton Carter, thank you so much.
Thank you.